Hello everyone. Today we'll be reading the third chapter in the NCERT textbook for Geography for Class 10. Water Resources. You already know that 3/4 of the Earth's surface is covered with water, but only a small proportion of it accounts for fresh water that can be put to use. This fresh water is mainly obtained from surface runoff and groundwater that is continually being renewed and recharged through the hydrological cycle. All water moves within the hydrological cycle, ensuring that water is a renewable resource. You might wonder that if 3/4 of the world is covered with water and water is a renewable resource, then how is it that countries and regions around the globe suffer from water scarcity? Why is it predicted that by 2025, nearly 2 billion people will live in absolute water scarcity? Water scarcity and the need for water conservation and management. Given the abundance and renewability of water, it is difficult to imagine that we may suffer from water scarcity. The moment we speak of water shortages, we immediately associate it with regions having low rainfall or those that are drought prone. We instantaneously visualize the deserts of Rajasthan and women balancing many mud cars, earthen pots used for collecting and storing water and traveling long distances to get water. True, the availability of water resource varies over space and time, mainly due to variations in seasonal and annual precipitation, but water scarcity in most cases is caused by overexploitation, excessive use, and unequal access to water among different social groups. Where is then water scarcity likely to occur? As you have read in the hydrological cycle, fresh water can be obtained directly from precipitation, surface runoff, and groundwater. Is it possible that an area or region may have ample water resources but is still facing water scarcity? Many of our cities are such examples. Thus, water scarcity may be an outcome of large and growing population and consequent greater demands for water and unequal access to it. A large population requires more water not only for domestic use but also to produce more food. Hence, to facilitate higher food grain production, water resources are being overexploited to expand irrigated areas for dry season agriculture. Irrigated agriculture is the largest consumer of water. Now it is needed to revolutionize the agriculture through developing drought-resistant crops and dry farming techniques. You may have seen in many television advertisements that most farmers have their own wells and tube wells in their farms for irrigation to increase their produce. But have you ever wondered what this could result in? That it may lead to falling groundwater levels, adversely affecting water availability and food security of the people. Post-independent India witnessed intensive industrialization and urbanization, creating vast opportunities for us. Today, large industrial houses are as commonplace as the industrial units of many MNCs, multinational corporations. The ever-increasing number of industries has made matters worse by exerting pressure on existing freshwater resources. Industries, apart from being heavy users of water, also require power to run them. Much of this energy comes from hydroelectric power. Today, in India, hydroelectric power contributes approximately 22% of the total electricity produced. Moreover, multiplying urban centers with large and dense populations and urban lifestyles have not only added to water and energy requirements but have further aggravated the problem. If you look into the housing societies or colonies in the cities, you would find that most of these have their own groundwater pumping devices to meet their water demands. Not surprisingly, we find that fragile water resources are being overexploited and have caused their depletion in several of these cities. So far, we have focused on the quantitative aspects of water scarcity. Now let us consider another situation where water is sufficiently available to meet the needs of the people, but the area still suffers from water scarcity. This scarcity may be due to bad quality of water. Lately, there has been a growing concern that even if there is ample water to meet the needs of the people, much of it may be polluted by domestic and industrial wastes, chemicals, pesticides, and fertilizers used in agriculture, thus making it hazardous for human use. Government of India has accorded highest priority to improve the quality of life and enhance ease of living of people, especially those living in rural areas, by announcing the Jal Jeevan Mission (JJM). The goal of JJM is to enable every rural household get assured supply of potable piped water at a service level of 55 liters per capita per day, regularly on long-term basis by ensuring functionality of the tap water connections. India's rivers, especially the smaller ones, have all turned into toxic streams. And even the big ones, like the Ganga and Yamuna, are far from being pure. The assault on India's rivers, from population growth, agricultural modernization, urbanization, and industrialization, is enormous and growing by the day. This entire life stands threatened. Source: The Citizen's Fifth Report, CSE 1999. You may have already realized that the need of the hour is to conserve and manage our water resources, to safeguard ourselves from health hazards, to ensure food security, continuation of our livelihoods and productive activities, and also to prevent degradation of our natural ecosystems. Overexploitation and mismanagement of water resources will impoverish this resource and cause ecological crises that may have profound impact on our lives. Multi-purpose river projects and integrated water resources management. But how do we conserve and manage water? Archaeological and historical records show that from ancient times we have been constructing sophisticated hydraulic structures like dams built of stone rubble, reservoirs or lakes, embankments and canals for irrigation. Not surprisingly, we have continued with this tradition in modern India by building dams in most of our river basins. Hydraulic structures in ancient India. In the 1st century BC, Sringaverapura near Allahabad had sophisticated water harvesting system channeling the floodwater of the river Ganga. During the time of Chandragupta Maurya, dams, lakes, and irrigation systems were extensively built. Evidences of sophisticated irrigation works have also been found in Kalinga, Odisha, Nagarjunakonda, Andhra Pradesh, Bennur, Karnataka, Kolhapur, Maharashtra, etc. In the 11th century, Bhopal Lake, one of the largest artificial lakes of its time, was built. In the 14th century, the tank in Hauz Qas, Delhi, was constructed by Iltutmish for supplying water to Siri Fort area. What are dams and how do they help us in conserving and managing water? Dams were traditionally built to impound rivers and rainwater that could be used later to irrigate agricultural fields. Today, dams are built not just for irrigation but for electricity generation, water supply for domestic and industrial uses, flood control, recreation, inland navigation, and fish breeding. Hence, dams are now referred to as multi-purpose projects where the many uses of the impounded water are integrated with one another. For example, in the Satluj Beas river basin, the Bakra Nangal project water is being used both for hydel power production and irrigation. Similarly, the Hirakud project in the Mahanadi basin integrates conservation of water with flood control. Multi-purpose projects launched after independence with the integrated water resource management approach were thought of as the vehicle that would lead the nation to development and progress, overcoming the handicap of its colonial past. Jawaharlal Nehru proudly proclaimed the dams as the temples of modern India, the reason being that it would integrate development of agriculture and the village economy with rapid industrialization and growth of the urban economy. A dam is a barrier across flowing water that obstructs, directs, or retards the flow, often creating a reservoir, lake, or impoundment. Dam refers to the reservoir rather than the structure. Most dams have a section called a spillway or weir over which or through which it is intended that water will flow either intermittently or continuously. Dams are classified according to structure, intended purpose, or height. Based on structure and the materials used, dams are classified as timber dams, embankment dams, or masonry dams, with several subtypes. According to the height, dams can be categorized as large dams and major dams, or alternatively as low dams, medium height dams, and high dams. In recent years, multi-purpose projects and large dams have come under great scrutiny and opposition for a variety of reasons. Regulating and damming of rivers affect their natural flow, causing poor sediment flow and excessive sedimentation at the bottom of the reservoir, resulting in rockier stream beds and poorer habitats for the river's aquatic life. Dams also fragment rivers, making it difficult for aquatic fauna to migrate, especially for spawning. The reservoirs that are created on the floodplains also submerge the existing vegetation and soil, leading to its decomposition over a period of time. Multi-purpose projects and large dams have also been the cause of many new environmental movements like the Narmada Bachao Andolan and the Tehri Dam Andolan, etc. Resistance to these projects has primarily been due to the large-scale displacement of local communities. Local people often had to give up their land, livelihood, and their meager access and control over resources for the greater good of the nation. So, if the local people are not benefiting from such projects, then who is benefited? Perhaps the landowners and large farmers, industrialists, and few urban centers. Take the case of the landless in a village. Does he really gain from such a project? Narmada Bachao Andolan or Save Narmada Movement is a non-governmental organization (NGO) that mobilized tribal people, farmers, environmentalists, and human rights activists against the Sardar Sarovar Dam being built across the Narmada River in Gujarat. It originally focused on the environmental issues related to trees that would be submerged under the dam water. Recently, it has refocused the aim to enable poor citizens, especially the oustees, displaced people, to get full rehabilitation facilities from the government. People felt that their suffering would not be in vain, accepted the trauma of displacement, believing in the promise of irrigated fields and plentiful harvests. So often the survivors of Rihant told us that they accepted their sufferings as sacrifice for the sake of their nation. But now, after 30 bitter years of being adrift, their livelihood having even been more precarious, they keep asking, are we the only ones chosen to make sacrifices for the nation? Irrigation has also changed the cropping pattern of many regions, with farmers shifting to water-intensive and commercial crops. This has great ecological consequences like salinization of the soil. At the same time, it has transformed the social landscape, that is, increasing the social gap between the richer landowners and the landless poor. As we can see, the dams did create conflicts between people wanting different uses and benefits from the same water resources. In Gujarat, the Sabarmati Basin farmers were agitated and almost caused a riot over the higher priority given to water supply in urban areas, particularly during droughts. Interstate water disputes are also becoming common with regard to sharing the costs and benefits of the multi-purpose project. Do you know that the Krishna Godavari dispute is due to the objections raised by Karnataka and Andhra Pradesh governments. It is regarding the diversion of more water at Koyna by the Maharashtra government for a multi-purpose project. This would reduce downstream flow in their states with adverse consequences for agriculture and industry. Most of the objections to the projects arose due to their failure to achieve the purposes for which they were built. Ironically, the dams that were constructed to control floods have triggered floods due to sedimentation in the reservoir. Moreover, the big dams have mostly been unsuccessful in controlling floods at the time of excessive rainfall. You may have seen or read how the release from dams during heavy rains aggravated the flood situation in Maharashtra and Gujarat in 2006. The floods have not only devastated life and property but also caused extensive soil erosion. Sedimentation also meant that the floodplains were deprived of silt and natural fertilizer, further adding on to the problem of land degradation. It was also observed that the multi-purpose projects induced earthquakes, caused waterborne diseases, and pests and pollution resulting from excessive use of water. Rainwater harvesting. Many thought that given the disadvantages and rising resistance against the multi-purpose projects, water harvesting system was a viable alternative, both socio-economically and environmentally. In ancient India, along with the sophisticated hydraulic structures, there existed an extraordinary tradition of water harvesting system. People had in-depth knowledge of rainfall regimes and soil types and developed wide-ranging techniques to harvest rainwater, groundwater, river water, and flood water in keeping with the local ecological conditions and their water needs. In hill and mountainous regions, people built diversion channels like the gulls or kulls of the western Himalayas for agriculture. Rooftop rainwater harvesting was commonly practiced to store drinking water, particularly in Rajasthan. In the floodplains of Bengal, people developed inundation channels to irrigate their fields. In arid and semi-arid regions, agricultural fields were converted into rain-fed storage structures that allowed the water to stand and moisten the soil, like the Khadins in Jaisalmer and Johars in other parts of Rajasthan. In the semi-arid and arid regions of Rajasthan, particularly in Bikaner, Phalodi and Barmer, almost all the houses traditionally had underground tanks or tankas for storing drinking water. The tanks could be as large as a big room. One household in Phalodi had a tank that was 6.1 meters deep, 4.27 meters long and 2.44 meters wide. The tankas were part of the well-developed rooftop rainwater harvesting system and were built inside the main house or the courtyard. They were connected to the sloping roofs of the houses through a pipe. Rain falling on the rooftops would travel down the pipe and was stored in these underground tankas. The first spell of rain was usually not collected as this would clean the roofs and the pipes. The rainwater from the subsequent showers was then collected. The rainwater can be stored in the tankas till the next rainfall, making it an extremely reliable source of drinking water when all other sources are dried up, particularly in the summers. Rainwater or palar pani, as commonly referred to in these parts, is considered the purest form of natural water. Many houses constructed underground rooms adjoining the tanka to beat the summer heat as it would keep the room cool. Rooftop rainwater harvesting is the most common practice in Shillong, Meghalaya. It is interesting because Cherrapunji and Mawsynram, situated at a distance of 55 km from Shillong, receive the highest rainfall in the world. Yet, the state capital Shillong faces acute shortage of water. Nearly every household in the city has a rooftop rainwater harvesting structure. Nearly 15 to 25% of the total water requirement of the household comes from rooftop rainwater harvesting. Today, in western Rajasthan, sadly, the the practice of rooftop rainwater harvesting is on the decline as plenty of water is available due to the perennial Indira Gandhi Canal, though some houses still maintain the tankas since they do not like the taste of tap water. Fortunately, in many parts of rural and urban India, rooftop rainwater harvesting is being successfully adapted to store and conserve water. In Gandatur, a remote backward village in Mysuru, Karnataka, villagers have installed in their households rooftop rainwater harvesting system to meet their water needs. Nearly 200 households have installed this system, and the village has earned the rare distinction of being rich in rainwater. Gandatur receives an annual precipitation of 1000 mm and with 80% of collection efficiency, and of about 10 fillings every house can collect and use about 50,000 liters of water annually. From the 200 houses, the net amount of rainwater harvested annually amounts to 1 lakh liters. Tamil Nadu is the first state in India which has made rooftop rainwater harvesting structure compulsory to all the houses across the state. There are legal provisions to punish the defaulters. And that is the end of the chapter. We will be reading the next chapter in the next video. Until then, stay tuned.